Hi! Today we're going to learn about the conditions for regression inference. Now the acronym that you have to know for the conditions for regression inference is LINER. L-I-N-E-R. The L stands for linear, independent, normal, equal variance, and randomness, or random. So let's go through each of these conditions, figure out what they mean, and how to see if the condition is met. Let's start with the simplest one, randomness, or random. So this is always stated in the problem. The problem always has to state whether the sample collected or the samples collected were random. So let's say a sample of 50 people is randomly selected from a population. So it has to be stated in the problem. There's no way around that. Now let's move on to the next thing. It's independence. So each sample has to be independent. So we can figure this out through two ways. So if you're selecting from a pool without replacement, then you have to follow the 10% condition. If you have replacement, then independence is a given. It's going to be independent. So, what is the 10% condition? Well, or independence, yes. It's just, okay. Yes, for it to be independent, you have to have the 10% condition. So what is the 10% condition? Well, the 10% condition basically says that n must be less than or equal to 10% of big N. So what does that mean? Well, it means your sample size has to be less than or equal to 10% of the population size. So, that's simple. And this is only for without replacement. Let me write that so you guys can see it. Without replacement. So now let's move on to linear. So when you're doing regression inference, it has to be linear. That's basically from the name. Regression inference is basically talking about the slopes. And so we want to see whether this is linear. The easiest way to do this is just looking at the R values. If the R value is strong, usually R is going to be greater than 0.95. The absolute value of R is going to be greater than 0.95. Then you have a linear function. Or we can just say R is strong. Another way of looking at this is looking at the R squared. The R squared basically shows us what percentage of the data can be represented using the best line of fit, or the least squared regression line. So basically we want R squared to be high, or R squared to be high, or really strong, because that shows that R would be even higher. So the absolute value of R squared, or it is squared, so it doesn't matter. So R squared would have to be high. Now let's talk about normality. So there are two ways to do this. So basically, there's actually just one way. So when we're talking about normality, we're not talking about the data itself. We have to talk about residual plots, and this is the same thing for equal variance. So let's go back to what a residual plot looks like. We have the x value And then we have the y values. It goes like this. And basically, the residual is the observed minus expected value. So, on a residual plot, we basically just plot the residuals down. So the x is the x value of the point, and the y is the residual value. So, when you have normality, let's draw something here, and you have your residual plot, you want your residual plot to look something like this. Or you want points on your residual plot, so let's say like this. And I'm doing a very bad job here, but yeah. So essentially, you want more points closer to the line of this, or closer to this central line here, which is 0. Now let's look at how this shows normality. Well, basically, when you want the residual plot, you want to have it look like this, so that the points are arranged in a normal fashion, like here. So that the residuals follow a normal curve. Now you can see this thing to the right here on most computer softwares when you do the residual plots. It doesn't happen on calculators though, so you just have to approximate. You basically want the residuals, most of the residuals, to be closer to this central line here and then fewer as you go out further. Now let's talk about equal variance. Yes, now let's talk about equal variance. Equal variance also has to do with the residual plot. This time we're only looking here. We basically want to see if the points are evenly spread out with each other. So that means we wouldn't want a residual plot like this. That's not good. We want the points to be equally spread out amongst each other. That's what equal variance shows. So we can also find equal variance from looking at the residual plot here. Today we learned about the conditions for regression inference. Thank you for watching this video.